There's been quite a drive in recent years to improve computing education in schools. Programming is now the national curriculum. Children get inspired of being taught to program. Unfortunately, most of the programming languages being used to teach programming are very visual. The syntax is drag and drop often, and the output is animated video. This is a very popular example, Scratch. So our project is to try and rectify the problem, which is that if you can't see, if you're visually impaired, it's just a frustrating waste of time to try and use languages like this. Our project aims to design a programming language which is easily accessible by visually impaired people and produces music instead of video for output. This is Sonic Pi, a programming language designed by Sam Aaron here in Computer Lab, designed for education, computer science and music. It's user-friendly, there's very little boilerplate code in the syntax, it's fairly similar to natural language. We used it. Our programming language system outputs Sonic Pi, which is then run by the Sonic Pi backend. The particular reason that we chose it is it facilitates live coding, which is what our project also aims to do. That is, a performer writing musical code live in front of an audience, so that as they edit the code, the music is updated orally live.
So these are Qubits, which are the other main part of our project. The original idea was to use these to represent their arrangement as a running Sonic Pi program. Unfortunately, we realised we couldn't do this due to the Bluetooth Qubit not being able to get the topology of the Qubits connected to it. So instead of that, we are using sensor Qubits to control values within Sonic Pi as they sense. For example, this can sense the temperature of a room. If you can imagine using it in a club, as the temperature of the club increases, it can make the music go faster and get louder. There are three main parts to our project. The front end represents Sonic Pi code in its tree structure and allows the user to navigate it simply using arrow keys and edit it with very simple keyboard shortcuts. We also have a thing that communicates with the Qubits. This is done through the Bluetooth Qubit, which sounds very simple, just reading the values of the 6 sides connected to it. But unfortunately, because the Qubits were originally designed just to make robots, the Bluetooth connection is very dodgy and doesn't work very well. That was the main issue with that. The back end of our project, though, is the real part. This is what takes the Sonic Pi from the front end and the values from the Qubits and puts them together and sends it to a Sonic Pi server, which is what actually generates your music. We were lucky enough to have actual product tests halfway through our project with 3 visually impaired children. This was a really valuable thing for us, as they were able to give us feedback on how to make our code more usable and child-friendly. For example, replacing certain bits of the Sonic Pi syntax with natural language when the screen reader read it out to them. Throughout the hour that we had with them, each of them was able to produce their own piece of music, which was really rewarding for us, and they all seemed to really enjoy it. They all went and told their friends how much fun they'd had, and now their friends seem to all want to go as well. It's really great. Thank you very much.